Okay, we're looking at section 9.3. All we're doing here is finding the critical t-score when we know it's a one-tailed test where alpha is 0.05 and n equals 12. And we're going to look up the table. We're actually using the table. So we know it's a one-tailed test. Here's one tail. And we know alpha is 0.05. And we know that n is 12. And so our degrees of freedom is always n minus 1, so 12 minus 1 would be 11. So go to your one tail 0.05 and go down to 11, and there is your critical value. Okay, you would do the same thing for this one, 0.01. So we will be a one-tailed in this column, and then n is 27. So our degrees of freedom would be one less, so 26. So our critical value would be 2.479. Now, for a two-tailed test, we're going to look at the same table, but we're going to go to two-tailed and find 0.05. Now, our degrees of freedom here in number 3 is n equals 14. So we would go to 13 for degrees of freedom. So with the two-tailed test, you have two critical values, negative 2.16 and positive 2.16. And then for the last one, we see n is 40, so we're going to use 39 as our degrees of freedom. You have to go to the second table. Alpha is 0.02, and then you're going to go down to 39. Oops, I went too far down. So negative 2.426 and positive 2.426. Looking at question 2, we're going to test a hypothesis. So we know the mean, we know the standard deviation, we know what n is, and we know what alpha is. I'm going to show you how to calculate your critical value by hand, and then I'm going to show you how to do it in StatCrunch. To calculate it by hand, you take the sample mean, which is 54.2. Remember, the sample mean is x bar minus the hypothesis mean, which is 60, divided by s, which is the standard deviation, divided by the square root of n, which is 30. So when you calculate that, you will get negative 1.699. If you do not get that when you calculate it by hand, or you get something different that's a little bit off, you might want to use StatCrunch instead. So how do we do this in StatCrunch? We go open StatCrunch up, and you're going to go to calculate, and you're going to go to calculate. We're going to go to Stat, Calculators, T. And your degrees of freedom is n minus 1. So 30 minus 1 would be 29. And then, okay, let me minimize this so I can see. If you put in alpha, which is 0.05, now this is a one-tailed test because it has greater than or less than. So it is a one-tailed test, and it's less than for the null. If it's less than, sorry, for the alternate. If it's less than for the alternate, it's less than is the left side. So let's look and see. So our critical value is negative 1.699. There it is. So I showed you how to calculate it by hand, and I showed you how to calculate it in StatCrunch. Now, to determine the test statistic, we're actually going to do this in StatCrunch. So we go to Stat, we go to T-Stats, one sample with summary, and we put in our sample mean, which is 54.2. We put in our standard deviation, which is 6.5. We put in our sample size, which is 30. Now I always put the hypothesis number in and then the confidence interval is already there. And you can see that your test statistic is negative 4.89. Now, we still have to understand what this means as far as rejecting or accepting. Now, this is a left tail test. So, first of all, our critical value is, I believe it was negative 1.699. So, anything less than that would be what I call the rejection area. So our test statistic is negative 4.89. So since it's less than our critical value, then it's in the rejection area. So looking at that, we would reject the null because there is sufficient evidence to conclude that there's enough evidence to conclude that the mean can be less than 60. So we would reject the null because of that. Now, to determine the p-value, let's see if I still have it open. I don't. Okay, so I should have left it open. But you can get the p-value when you calculate what we just calculated. And I didn't save it. So I'm going to have to go through it again, which is okay because we can kind of review with summary data. The sample mean was 54.2. The standard deviation was 6.5. The sample size was 30. This was 60. And click on p-value plot and hit compute. So we know that the p-value plot is less than 0.0001, so you can just type in 0.000. Okay, and this one is very similar to the last one, but it just has an equal sign. So this is a two-tailed test. So it says determine the critical value, and you could do it by hand or you could use StatCrunch. I'm going to use StatCrunch because of time, but I showed you in the last example how to do that by hand. So you would go to Stat, Calculators, and go to T, and the degrees of freedom is always n-1, so that's 29. And then over here, we're going to take alpha and divide it by 2 since it's a two-tailed test. So this is going to be 0.025. And you will see that our critical value is negative 2.045 for your left. And then to do the right, it would be the same thing, positive 2.045. Now to determine the test statistic, you can, one way to do this is to let's see. Let's just do the way we've been doing it. Calculator. To get the test statistic, you do t-stats, one sample with summary. And the sample mean is 60, and the sample standard deviation is 20. The sample size is 30, and the hypothesis is that it's equal to 50. And then the confidence interval. Alright, so let's click on p-value plot this time. So you can see that the test statistic is 2.74, and the p-value is 0.010. So there's the p-value if you want to see it. Now, let's think about our test here. So we know that the critical value I'm going to have to scroll up. The critical value is negative 2.045 and positive 2.045. Alright, so let's draw that. Negative and positive. The areas of rejection are the left of this and to the right of this. Okay, so our test statistic is 2.74, which would be above 2.04. So we can reject it because the data provides sufficient evidence that the mean differs from what the null is. Okay? Because since we're rejecting it, that means we're finding evidence that it is different from the null. We're rejecting the null. Okay, now let's move on and just go through and look. Question number 4. Now, what you can do here is you can click on this and you can calculate the mean and standard deviation and all of that if you want to review that. But you can open this in StatCrunch. Okay, now for the critical values, you can go ahead and just go to T, because all you need for the critical value is the degrees of freedom, and alpha is 0.05. So the degrees of freedom, how many numbers do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So degrees of freedom is 9. And then it's a one-tailed test, so we can say alpha is 0.05. So our critical value is negative 1.833. Now to determine the test statistic, you still go to stats and T-stats and one sample, but you put not with summary because we don't have the summary, we put with data. And then you can put, for the hypothesis, 14, and then you can look through here. I don't think we need any of this, but let's hit compute. So we can see here that our test statistic is 3.63 and our p-value is 0.006. So our p-value, hold on, we have to divide that number by 2, I believe, to get our p-value. Let me make sure. 9. I believe that's what I had to do. Or we can go back and enter in our standard deviation and all that to get the p-value. We'll go back to that in just a second. Let's look at our hypothesis. So we know that this is 9.3.4. We know that our critical value was 1.833, and we know that anything above that is we would reject. Our test statistic is above that, it's 3.63. So we can reject the null because there's sufficient evidence to conclude that the alternate may be true. Okay, there's sufficient evidence to conclude that this may be true, and it doesn't support the null. Okay. Now what I did to get the p-value is I use the information